Hola, mi clase. All right, we're doing 6.3, part 1, and we're talking about exponential growth. So still exponents, and we're going to talk about things that grow, so increase exponentially. So one of the things we're going to talk about is compound interest. And compound interest is that is paid both on the principal and on the interest. So compound meaning two things, right? Compound word, two words, that has already been paid. It's an exponential growth function. Okay. Now, exponential growth, which I don't have the definition. Hold on, pause. I'll be back. All right, here's what I came up with. So increase in amount exponentially, or meaning not constant, right? So from one point to the next, it would grow quicker and not like just by +2, it would be like times by 2, right? So it's not constant, so the jumps are bigger. And then we have what's called a growth factor, and it's 1 plus the growth rate. And this rate will normally be a percentage. Okay, so down below we have two equations. So you can model exponential growth with a function f of x equals a times b to the x. That's the one we worked on yesterday, or in 6.2. And then for a compound or like exponential growth, we have f of x equals a parentheses 1, there's our 1, plus our rate. R stands for rate. And then we raise that whole thing to the power of our x, okay? And this is where we have our growth factor, okay? So the population of Hillville is 5,000. So that's our A, right? Our A is still what we start with, right? A doesn't change. It's just that our B is going to slightly change because it's now exponentially growing at a rate instead of finding that constant ratio. So then it says it has an annual rate of 15%. When we have our rate of 15%, we need to remember to change it to a decimal, okay? And then when it says, what will the estimated population of Hillville be in 5 years? So we're going to use this bottom one because we have a rate and not a constant ratio. So we're going to go f of x equals our A, remember, was 5,000. And then we're going to go parentheses. It's always 1 plus my rate and then raised to the x. We can combine these, and so we could have a final one of 5,000 and then 1 and 1/1500 x. So then once we have our equation, so that our function, so that we can use it to predict other information, we can plug it in what we need to find. So it says in 5 years. So now x is going to become 5. See here it says 5 years, so this is now our x. So I'm going to go 5,000 times 1 and 1/1500 raised to the 5th power. So this is where your calculator will come in handy, okay? So we need to learn how to do these things on our calculators. I'm going to go 1 and 1/1500. I'm going to raise it to the 5th power. Now it's a really crazy decimal. Okay, it's like 2.011357188. That's all the decimals I have. I'm going to just push. I'm not going to clear that. I'm going to go just times, and I'm going to put 5,000, and I get approximately, and it's 10,056.78, blah, 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 blah. And so depending on the question and where it says to round, so we could say about 10,000, and let's just round it up, 56 people. We'll just use true rounding rules, and we'll round to the nearest whole number. And that would be our answer. This is our estimate. okay? The other reason we're going to round it is because we wouldn't have fractional people. That's a little weird. And so we need to make sure we have real true answers. All right, so the population of Valleytown is also 5,000. So if we, that's important. That's our initial value. And it has an annual increase. So annual means 1 year, okay? So annual equals each year. And it's an increase of 1,000 annually, every year. Can the expected population of Valleytown be modeled with an exponential growth function? And we would need to explain. So, do we have a rate in this one? No. Do we have a constant ratio? Do we even know what next year is? Well, we do know what next year would be. We would just increase the initial by 1,000. So, right, our starting point is 5,000. After a year later, it would be 6,000. 2 years, it would be 7,000. So we can see this is not exponential because we're just adding 1,000. Exponential ends up with a ratio and it's a multiplication, not just an adding. So we would say no because it's a constant linear growth, not a constant exponential growth. It's not a multiplication of, it's an adding of. All right, so we're just going to practice writing exponential growth functions for each situation. So that's like the first problem we did. So maybe push pause here and try number 1. And then see if you wrote the correct equation, and then same for number 2. So for the first one, I'd go f of x equals 100, parentheses, 1 plus, now be careful with this percentage, it's actually 0.05. You have to move the decimal over twice to the x. And so my final answer cleaned up would be f of x equals 100, parentheses, 1 500 x. And then again, pause here, try number 2. So I would do f of x equals 1,250, and it would be 1 2500 x. So this time I kind of skipped this step. So let's see if you can figure out, if you had an issue, see if you can figure out what happened. All right, so Kimberly's family invested in a certificate of deposit, called CD, for her when she was born. The interest is compounded quarterly. So quarterly means 1/4, right? Quarter something. So in a year, they would do it 4 times. Okay, so this is a compound interest formula. A is equal to the amount you get paid. P is equal to our principal amount. We would also could call this our initial amount. Which in our other equation, it was considered our A. It's it's actually the same thing. There's our R, rate of interest, right? We still have our +1, there's our R. Now, N is the number of times per year the interest is compounded. So this is where that quarterly comes in. So that's equal to 4, right? 1/4. So they do it 4 times a year. And then T is equal time in years. Okay, so it wants to know what is the value of the CD, not the compact disc, at the end of 5 years. So the first thing we would have to do is find what it would need to be, or what the formula would be to find this, right? So let's fill in everything we know. We're trying to find A, so that's going to stay as A. The principal amount is listed here. It says the amount deposited was $3,000. We're going to go 1 plus, the annual interest rate is 8%, so that's 0.0 0.08. And then we're going to put it over quarterly. Remember, that's 4 times. And then we'll go parentheses. And if you notice, the n shows up here too. So we go 4. And then in this case, it's 5 years. So I'm going to go parentheses 5. Okay, because remember, time is 5 years. All right. So I'm going to do some cleanup. So I would go 3,000 parentheses 1 plus, I'm going to make it that bigger. I'm going to use my calculator. I'm going to go 0.08 divided by 4. It gets me 0.02. And then 4 times 5 gets me 20. So I'm going to do a little bit more cleanup. I'm going to go 3,000 parentheses 1.02. I just added those together, raised to the 20th. Now, in my calculator, I'm going to go 1.02. I'm going to raise it to the 20th power. It's 1.4859, really big decimal. So again, I'm not going to clear it. I'm going to go times 3,000, and it's going to be about 44,057. Oh, I lied. Sorry, put my comma in the wrong place. $4,057.84. Now there's a lot more decimals, but because I'm talking about money, I wouldn't go past that. So that's what it's valued after 5 years. All right. Will the value of Kimberly CD be greater after 15 years if it is a compounded annually rather than quarterly? So we actually have to do 2 different equations here, functions here. We're going to do one for when it's quarterly, and then we're going to do one where it's annually. So annually would just be 1 time a year, right? This is 1 time, this is 4 times. So we're going to do 2 functions. A equals 3,000, 1 plus 0.08 over 4, that's my quarterly one, and then 4 times 15, that's my time. And then for my annual one, I'm going to put over here, A equals 3,000 times 1 plus 0.08 over 1, and then 1 times 15. All right, I want you to try to do these in your calculator like we did A, and see if you can get the answers to these and see what you got. And then I'm actually going to leave this one blank, and I want you to answer both of these and then tell me, will the value of the CD be greater after 15 years if it was compounded annually instead of quarterly? So I set them up for you. You're just going to finish them. All right, an account is opened with a deposit of $5,000. Okay, so there's our initial value. It earns an interest rate, that E got cut off, at 6%. This is compounded monthly. Monthly for the year is 12 times, right? Remember our formula, it says number of times per year the interest is compounded. So since it says monthly, that's 12. How much interest was earned after 12 years? What is the total value of the account after 12 years? Okay, so compound interest. A equals 5,000, parentheses, 1 plus my interest at a decimal over 12 because it's 12 times a year, and then 12 times my years is 12. All right, so I'm going to clean this up a little bit. So it's going to become 5,000 and then 1.005. That's this put together. And then 12 times 12 is 144. So this is where definitely need my calculator. We're going to raise it to the 144. We're going to then, it's 2.05 blah, blah, blah times 5,000. And so we would get 10,253.75. So that's our first question. This is after 12 years. This is how much I earn. Now, the second part of this question says, what's the total value of the account after 12 years? Well, this is how much I earned, but remember, I started with this. So to find the total, I'm going to take that, what we call principal, and I'm going to add it to my A, or my amount earned. So it would be 5,000 plus my $10,253.75. And so my total would be $15,253.75. And there's our two answers. Remember, with money, we always stop and round at pennies. That's a really bad money sign, I'm sorry. All right, so the main things to remember are those formulas. Memorize the formulas. I know that there's now 3, but it's really important to memorize them, okay? We have just a normal exponential function. We have our one with a rate, which is like this, and then we have one that's compound interest very specifically, okay? So your independent practice is just to write the function for this situation, so you don't have to find any answers, time, or anything. So just go and find the function that if I wanted to find it for like 3 years, 8 years, 6 years, whatever, what would it be? All right, until next time, adios.